The question we are solving now belongs to test series 7. It is of signals and systems subject. In specific, it belongs to frequency representation of signals. As per the question, there is a discrete time signal x of n whose Fourier transform is given as x of e power j omega. It is given that x of e power j omega is purely imaginary. The signal x of n has values at the instant n is equal to 0 as j, and at n is equal to 1 its value is 1 plus j. We need to find the value of the signal at n is equal to minus 1. From the given data we see that as x of e power j omega is purely imaginary, it implies that x of n is conjugate skew symmetric. This is based on the properties of frequency representation of signals. That is, if a signal x of n is conjugate skew symmetric, its frequency representation is purely imaginary. As the signal is conjugate skew symmetric, we can write that x of n is equal to minus x star of minus n. This is based on the conjugate skew symmetric property of the signal. If we substitute n is equal to minus 1, we see that x of minus 1 is equal to minus x star of 1. It is already given that x of 1 is equal to 1 plus j. Upon substitution, we see that this is equal to minus of the conjugation of 1 plus j. This can be written as minus of 1 minus j, and upon simplification, this becomes minus 1 plus j. Hence, we see that the value of the signal at n is equal to minus 1, that is x of minus 1 is minus 1 plus j. Hence, the correct option which represents the value of x of minus 1 is B.